In this demo, we're going to look at how you can achieve the highest levels of control, trust, and transparency by integrating Thales CipherTrust Cloud Key Manager with AWS XKS. At the center of my taskbar, I have two different Chrome windows. In the first window, I am logged in as root under my XKS account. And under Amazon S3 services, if we select buckets, we can see that I have a single bucket. And inside this bucket, I have a single object. If I select the object, I can see the metadata and properties information about the object. And if I scroll down a bit, we can see the security and access to this object is being protected by this key. If we click the key, AWS will open a new tab and redirect it directly to that key, whereas root, I can see all the metadata and properties information about the key policy, the tags, the alias names, and the cryptographic configuration information, which under origin, we can see this key as an XKS key that is being used to protect all objects inside the bucket. Now I'm going to copy the key ID and then switch over to the second window where I'm logged into my CipherTrust manager. Inside the Cloud Key Manager tile, we can get a bird's eye view of all of our cryptographic keys across multiple accounts, multiple regions, and even between cloud and SaaS providers. However, the key we're looking for is in AWS, but more specifically, it is in my XKS account, which if I filter down to, I can see I have 3 keys totals, all in the US1 region. And if I search for the key ID I copied earlier, I can see this is the source key that is being used to double encrypt the data encryption key that AWS XKS is sending to our CipherTrust Cloud Key Manager. And if I select the alias name, we can see the same metadata and properties information that root was able to see from the AWS console. But we have a problem. This key is using the default key policy, which allows anyone with IAM KMS permissions to view and manage the key. If we're going to use an XKS key, then the first step we need to take is to take control of our key by applying our custom key policy, which as soon as I click Update, switch back to the AWS console, we can see root is automatically denied access to the key, and root has godlike privileges. However, if root or any other principal meets the conditions defined by our key policy, then they should be able to continue to access the objects protected by the XKS key. So far, everything seems to be working as intended, but now we have another problem. We have just been notified that the cloud provider has been subpoenaed into disclosing our most critical data and critical information. To prevent from having any of our data disclosed without our consent, we need to take some sort of action. However, we need to be able to recover regardless of the action we take. If we switch back to our CipherTrust Cloud Key Manager and look at the keys under my XKS account, we can see this key at the bottom is a customer managed key. If our data was being protected by this key, then our only option is to disable the key. But what prevents anybody else from simply re-enabling the key to access our data? Now, what if our data was being protected by a key that we provided or imported, also known as bring your own key? Our only options now is to disable the key or delete the key material, which as soon as I do, I've made all data previously protected by this key unreadable to anyone. But there's still that small risk of importing our keys into a cloud provider's key management service. To remove this risk from the equation, we need to trust the cloud providers less. And the way we do this is by blocking the trust relationship between Thales CipherTrust Cloud Key Manager and AWS XKS using keys stored outside the cloud provider's control. Now, if root tries to access the object that was once protected by this external key, root and every other user or role, including AWS, will be denied access. And we get this error message about needing to re-enable the external key to allow access. If I try to access the object 2 more times, and then go back to my CipherTrust Manager console, look at my records, I can see we have 3 independent auto records for each attempt I made with complete visibility and transparency into every encryption request, showing us who, why, and what action they attempted to perform against our data, and so much more. Thank you for watching.